Good afternoon and good morning, everyone. My name is Aman Jain, and I work at Amazon in a product and technology role focused on manufacturing, supply chain, data, and operation systems. My background has been in the intersection of business processes, engineering systems, manufacturing execution systems, ERP, PLM, analytics, and the product strategy. So I worked with teams that support manufacturing execution, quality planning, and data-driven decision making across very complex operational environments. So today I'm going to talk about AI-powered MES optimization. MES stands for the Manufacturing Execution Systems. So the core idea is simple. MES should only record what happened on a shop floor because it's an execution system of what's happening on a manufacturing shop floor. So that's what it should record. Without the right data or the AI layer, the MES can help operators, uh, cannot help operators or leaders, to actually understand what's happening now. So basically, that's what we want to do. We want to introduce this AI layer for them to understand what's happening, but also in addition to predict what is likely to happen next and recommend or trigger actions, before any disruption occurs. So that's what we are going to talk about. And for this session, I'll keep the discussion practical. I'm not going to position AI as a replacement for operators, planners, or engineers, manufacturing engineers, or the supervisors. The real value is embedded AI, the intelligence built into the MES workflow, where people already execute the work. AI should augment these decisions, it should reduce the response time, it should help the manufacturing teams, to move from reactive operations to the productive execution. So that's what the goal of this session is. Okay. So with that, I will move to the next slide. Uh, we are going to talk into the next state, which is more like understanding the problem statement here. Now, some of you who might be aware of the manufacturing shop floors or might have visited, they're still operating in a very reactive mode. The power of AI has reached the software industry, okay, or the tech industry, but it's still slow when it comes to the legacy models which is getting operated in the manufacturing world. Now, let's say a quality issue is found after the unit has moved, like let's say downstream, and it could be like a machine has failed, before the maintenance get involved, and the bottleneck is visible only after, let's say, there is some downstream queue which is already building up on the manufacturing line. So there could be multiple things like that. If you think of it, there are three main pain points. Okay, one is like the data across all these systems are siloed. Okay, they are not talking to each other. The production, the quality, the equipment, or the maintenance data, they often sit in separate systems, so they are not talking to each other. That's where I said they are siloed. Second is that the decisions are delayed. Okay, because the operators and supervisors do not have the real time insight. Okay, they're only executing based on what they learn or hear, from people. And the third part of this is like unplanned downtime, okay, which creates your direct cost, your lost throughput, or yielding the impact of it. So that is why you need, or we need, the MES systems, okay, to evolve. It's no longer enough for MES to be only like a record and report system, but the opportunity is to use AI to turn the operational data into timely decisions, before any issue becomes super expensive. So that's what our challenges or the problem area is. Now, having said that, it's a good time to now turn the page to the opportunity. The shift is, again, as I told before, it's from record and report to predict and optimize. Traditional MES captures production execution. Your AI-enabled MES opportunity is analyzing, that the execution data, and it connects to the equipment, quality, scheduling, and all those sort of things. Okay, it could even connect to the upstream and the downstream systems, like your ERP systems, your PLM systems, and everything else. So you can think of it as a uh, four step loop, where we are collecting the data, okay, which is basically ingesting the data from all these machine sensors, ERP systems, quality systems, and everything. Then you are analyzing it, where you're actually applying the ML models to detect the anomalies, patterns, constraints. And then we are recommending something, okay, which is like surfacing the prioritized or the actionable insights to operators, to supervisors, to planners, to maintenance team. Okay, that's what we are trying to do. and then based on that we finally act. Like in mature environments, basically, you're trying to trigger guided and autonomous responses within approved boundaries. Now this is not uh, like a separate you know AI dashboard or something, where we have to remember how to checklist. The value is basically how we embed AI in the whole workflow in a context, okay, against the active order or the work center machine, and all those sort of things. And we need to do it in phases, means we need to definitely have a ingestion layer of the data before we go to analyze mode or to recommend mode and act mode. Because oftentimes you've seen, what happens is that teams directly jump to act mode, they start building agents on certain things, but then the problem is the data itself, the surface itself is not very good. Okay, so that's what has to be taken care of. So having said that, now we have understood the problem, we have understood the opportunity here. So the agenda for today again will be, we will cover it through five areas. Okay, first we will look into like how the AI plus the MES architecture, okay, how it could be, and how it integrates with the current legacy MES platforms. Okay, so that's what we will do first. We'll then go into like operational intelligence and real-time visibility. Okay, what are those sort of things we can enable? And then from here we will up level it to like predictive maintenance. Okay, that because this is like one of the highest value use cases you will often hear when you will go and visit any of the manufacturing facilities. The fourth is about your scheduling and resource optimization, because that's equally important. You need to understand like how you will do all these things. And then obviously then we are talking about an adoption, because all these things coming into a place into a manufacturing environment where people are used to work in a fixed SOP kind of the things. It's very difficult sometimes to make it adoptable. Okay, so the practical adaptation, yeah, adoption of it, with data integration, governance, change management. Okay, so as we go through the deck, I'll try to address through two practical questions here. What data inputs matter the most, for AI and MES? Okay, that's one thing. And like how an organization can overcome integration challenges and scale their solutions effectively. Okay, so that's what we are going to learn about. Uh, Moving further, okay, let me try to explain this MES architecture, okay, to this. So AI again, it's not about like here we are trying to replace the MES system or replacing the people, okay, who are doing it. It's basically augmenting it, okay. MES remains the operational execution layer, okay, with the system of records for production orders, operating, routing, maybe your work centers, quality, material consumption, status, all sort of things, are coming together into it. But AI sits as an intelligence layer that uses this context to generate the insights. Okay. Now, if I talk through the layers of it, okay, again, keeping it very simple, there is the data ingestion layer, which we previously talked about, okay. You have PLCs, like the machines or the equipments, okay. ERP, the sensors, the transactions, okay, what are happening. Some protocols, okay, maybe some APIs, These are some examples of how data can move between the machines in an analytics environment and can be stored. The AI or ML engine, it performs basically an anomaly detection, maybe regression, maybe optimization, maybe diagnostic, okay, those kind of things. So LLMs may also assist with probably troubleshooting, summarization, operator guidance, but only when grounded in accurate operational context, right? So that's where the AI ML engine comes. And then the MES integration layer, okay, which is critical. Insights must flow back into MES, okay. It should inform it. If a model produces an insight but the operator never sees it at the point of action, the model does not create operational value, correct? So that's what it is. The architecture matters because the embedded AI requires a closed loop. Okay, data in, intelligence cover, generated, actions pushed back to the shop floor. Okay, so that's how the whole loop runs. Hopefully, it's easy enough to understand. How from the lens, how I am trying to look at it. So moving further, okay, now we have understood how the architecture could be. That's the other thing here is the, as we talked about, operational intelligence and real-time visibility. Okay. Now operational intelligence is basically the AI powered MES. It creates this unified operational picture by fusing the data streams which we earlier talked about, that lived in silos. Okay, so it's trying to bring it all together. The goal is to help supervisors, engineers act on developing issues, not the completed events, right? So that's what it is going to do. Uh, so example could be like, like let's say a cycle time is increasing on a work center. Okay, and the work in progress begins to accumulate up a street. Okay, so AI can flag that the station is emerging choke point, not necessarily when it becomes a choke point. It just earlier can tell it that it's becoming a choke point. It could be like inline quality monitoring. It can combine vision systems, sensor data, inspection results, okay, to catch the defects at the point of production. This reduces scrap, rework, downstream disruption. And again, like, the value is not just like, just like a dashboard. Okay, it's a value system telling the right person, here's the issue, here's the likely cause of it, here's the expected impact of it, and here is what action you need to consider, right? So that completes your closed loop of how the real time visibility can come into the place. Now moving further, which operational data points matter the most. Okay, so the slide already answers one of the key questions here. What are the most critical data inputs required to successfully implement AI in MES environments, right? So that's what I'm trying to cover here. So the data categories could be, your machine cycle times, operational equipment effectiveness, foundation. They're more foundational because they show the line performance, the hidden capacity loss, the throughput variances, right? The in-process quality measurement. It connects the defects and the drift to specific work orders, operations. Your equipment sensor telemetry, it is the raw material for predictive maintenance, vibration, temperature, those sort of things. Labor and material transactions, they provide the operational context, who performed the work, what skill was required, what material was consumed, whether the process matched the plan or not. So again, not the data is equal, okay? Not all the data is equal. You have to prioritize the high frequency, timestamp things, okay, that are tied directly to a production outcome, okay. There could be multiple production outcomes. That could be throughput, quality, downtime, cost, or safety. So depending on the context, depending on like what the manufacturing industry or the organization you're working for, what they need, this all can be shaped up. Okay. So hopefully again now this tells you like which operational data might be most important. Okay. So now I think we have covered the things about the data, okay, and the real time intelligence visibility. So moving forward, let's just talk about the predictive maintenance. Okay, so predictive maintenance is what? It's just often one of the fastest AI use cases, okay, to justify, because business impact is easy to understand. Okay, if you're predicting the failures, okay, unplanned failures basically, better equipment availability you're providing, okay, and more stable production line, that's the best. Okay, that's the best way to do the predictive maintenance. Now the old way to do is usually time based, okay, schedule based. This can lead to two problems. Okay, maintenance could happen too early, which wastes capacity, or maintenance too late, okay, which can cause unplanned downtime. So AI enabled maintenance is condition based. Okay, it looks at how equipment is actually behaving, detects like your degradation signatures before failure occurs. So again, tying it back to MES, the power comes when the maintenance insight is connected to production context, right? The system should know not only the asset is degrading, but also what orders are running, what demand is due, and what is the least disruptive maintenance window, right? So once it all comes together, it's most beneficial for them. So yeah, like hopefully, like this is making sense of what the predictive maintenance with machine learning it could be. Now, taking it further, how it works. Okay, the process starts like think of it from a sensor collecting all the data. Okay, it's collecting vibration data, temperature, pressure, maybe faults. Okay, run hour data. Okay, all those kind of things. Next is goes into the anomaly detection. Okay, the model learns the normal operating envelope, the flags deviation. Okay, this is valuable because many failures do not appear suddenly. Okay, it appears over a time. Then the failure prediction estimates the likelihood and urgency of failures. Okay, this is where confidence intervals matter. Okay, we need to avoid too many false positives, or operators will stop trusting the system. Right, that's also important. Finally, now from here, what will happen is that the system should create or recommend a work order. But this is where MES and maintenance system schedule system needs to connect. So in short, the critical enabler is the continuous baseline learning. Okay, the model improves. Okay, as it sees more normal, abnormal operating patterns over the time. Okay, so that's how, like, if you can think of, like, how from just a sensor signal. Okay, it translates itself into a maintenance action. Okay. Um, so I hope that that brings up clarity about the maintenance side of the things. Uh, let's take a step further. Okay, this is more about scheduling and resource optimization. Scheduling is more about like that how do you schedule your jobs, how do you schedule your resource allocations, those kind of things. So manufacturing scheduling is often very difficult, because the inputs keep on changing. Demand change, material changes, labor availability changes, machine is degrading, or priorities are shifting. So this static scheduling cannot keep up to the level of variation. So AI-driven scheduling uses constraint optimization, okay, and learning techniques to continuously rebalance labor, machines, materials against changing production priorities. Okay, so that's what AI scheduling is. And then the dynamic resequencing, it just basically means like, let's say the system can recommend that you have to reorder work, when the demand or machine status and material availability changes. Label allocation means like you're matching certified and available operators at the right task. Same way with material synchronization. You're meaning like ensuring, uh, let's say, the component availability with the production sequencing so that the work in progress and the line starvation are reduced. So again, the goal is not here the perfect automation. The goal is better data visibility and the faster scheduling decisions. Okay, so that's how like you can think of like how the scheduling and the resource optimization, it has completely changed over a period of time or will change, okay, as we move forward. uh, Now, closing the loop, okay, into this, like the maturity levels. There are different maturity levels as we work through this, okay. Like, so this slide more presents of a maturity part, which I feel like, could be from insights to action. The first step here is like, again, like monitor, okay. You could have dashboards, you could have alerts with human taking action into it, okay. The next level could be like advice, okay. The AI ranks recommendation, an operator approves that, okay, this is good, we should do it. The third level could be assess. The AI executes, it starts executing a low risk adjustments, right? And the human just reviews it. And the fourth loop is obviously like autonomy. That's the best part, where like there could be closed loop optimization across scheduling, quality, maintenance. So autonomy should not be introduced at all, like once. In manufacturing, quality, compliance, judgment really matters, and that's how those industries are operated. So human in a loop governance is essential, but does not mean that we have to always do it. There are certain decisions where you can go to certain places where it could just be in an autonomous state. Okay, so the right question is not like can AI automate everything, but maybe the right question is that with decisions can AI safely recommend, with low risk actions can it automate, and where can human approval be still required, right? So those kind of things, like I think as a team, between the tech and the ops, this has to be discussed, this has to be understood, okay, so that it could have things around it, right? uh, Now moving forward, okay, now let's talk more about like what is the practical adoption things about it, okay, how we can do it. So technology readiness is really the only barrier. Many organizations can build a model, but they struggle to operationalize it. Successful integrations again lays down on multiple foundations. One of them is data governance, okay. The other one is like your system architecture, the organization change management. So data governance ensures the model is using trusted and traceable inputs, okay. System architecture ensures like your insight can move across MES, ERP, SCADA, quality maintenance system, and the change management ensures operators and supervisors trust and use the recommendation, right? So that's how it is, when the things become practical, uh, you know, into the things. Uh, Now moving it further, let's talk about like how you build your AI MES roadmap, okay? Because that's equally important as a product manager, as a leader, driving all these initiatives. So here is a framework, okay, which I've placed. I think like it might work. Is that first you need to address the data silos. I had repeated this multiple times, but we need to have the data silos integrated, okay, in a way that the systems are having the same kind of things. Let's say the timestamps and everything. So AI is not only good as it's input, the fragmented sources lead to fragmented predictions, right? So unified data layer does not mean replacing every system, and it means like connecting the most critical signals with the, let's say, the consistent identifiers and timestamps. Second, we integrate. Okay, we do not replace, but we integrate. Most manufacturers, they have significant investments in MES, ERP, SCADA, quality systems. So AI should be an augmentation layer. It should be able to protect those investments and reduce the deployment risk. So third, again, there could be like a champion change management. Operators must understand, why the AI is recommending something. Explainable AI, your confidence scores, the training, the phased rollout, these are some hard topics, okay, which really are needed for the adoption. So that's how, the organizations can move from just foundations to intelligence to optimization, and that's how they should focus on, and then start building their roadmaps through this. uh, Now, going further into this, some key takeaways are there, obviously, for this, that uh, we should we should have the data input question explicit. Okay, that if an organization is starting AI in MES, the first step is not to collect every possible signal. The first step is identifying decisions we want to improve, and then prioritize those inputs required to for those decisions. Right. So that's how it should be. The production execution signals, they support the bottleneck detection and throughput optimization. Your equipment health, it will support your predictive maintenance. The quality and process signals, they support early drift detection. Material labor, they can support your scheduling and resource allocation. And obviously, your master data and time alignment that makes the model trustworthy. So business outcome linkage, it ensures the input maps into a measurable decision, right? So that's what it is. So more data does not automatically mean that better AI is there. Better AI comes from a reliable, timestamp, contextualized data, tied to outcome. So this is where, I think the AI drives the most measurable value. Okay, for the MES system. Um, uh, and some key things I also want to talk about is that um some critical data inputs. Okay, we already talked about that how for AI in MES, it could help out. There is also overcoming the things for integration challenges and scaling across AI MES systems, right? So this is where uh, one message I do want to communicate is that we have to start with the decision, okay, which we want to improve. Okay, then we should connect it to the data which is needed for the decision. Okay, in that way, you know that what are you trying to work backwards from. Okay, you know that. Then you embed the intelligence into the MES workflow. We talked about multiple ways how it could be integrated, and then scale only after we have the operators or the supervisors, they're able to trust it. Okay, so that's how, is the best way of overcoming the integration challenges in the scaling of AI or MES systems. Okay. Uh, and then more data, as I already said, it does not mean the better AI, but it's just like better AI comes with the right mechanisms you have set up with everything. You should have a standardized governance. You should embed, AI into MES workflow. Recommendations must appear, where work is performed, and then govern autonomy. Okay, in phases. Okay, move from monitor to advise to assess to autonomy. We talked about it, right? So those kind of things, and then scale with repeatable patterns. Okay, once you know that one line, one workflow is working, it proves value. You reuse that. You create the data models. You create that alert logic and adoption playbooks, right? So that's how you integrate all of it and go with it. Uh, but that's in general, how you can bring in the AI in MES, okay, into the shop floor. Uh, but yeah, that's about it, for my presentation today. I hope it was meaningful. You were able to gain insights, of how to implement it. But yeah, if there are any questions, feel free to reach out to me, and I would be more than happy to answer any of your questions. Thank you.